Hey students, let's look at this question here, which was taken from the year 2017 paper on question 8. So this question is on complex numbers. Do not use a calculator in answering this question. The first part, find the roots of this equation, giving your answer in the form of a plus b. Okay, now I think the first thing is to understand, if they ask you not to use calculator, just use calculator. Find the solution. Actually, you could use a calculator to check your answer first, then you have to work towards it. Okay, the first thing is know that this is a quadratic equation, so we could just use z equals to minus b plus minus b square minus 4ac, okay, over 2a, which is 1 minus I. Okay, then we're just gonna key in calculator and check for our answer there. So from here, key in calculator, just understand that this is a syntax for plus minus 1, but if not, you could just key in 2 lines, right? This is minus 1 plus 2i and 2 minus I. That's what we need to get. So we could just start by doing the same thing. Maybe we just check what does this, actually just key in calculator and see what is this value, the one inside the root, the discriminant. What's the discriminant there? So keying in would be 4 minus 4, 1 minus I, 5 plus 5i. Okay, it gives us negative 36, which is good, because if we were to expand it, then we could actually find the solution straight. So that's that. Without using calculator, we can do that. So to find this, I'm just going to take out the discriminant first. Okay, we know that it's negative 36 by using calculator. But of course, you need to show it. Minus 2 squared minus 4, 1 minus. I don't want to keep writing this, so I'm going to work this out first. Okay, so this will be 4 minus 4 bracket 5 minus plus 5i minus 5i minus 5i square. Okay, I square would be positive negative 1, then it will be positive 5 with 4 minus 4, 5 plus 0i plus 5. This is, there you go, get minus 36. So this guy will be minus 2 plus minus negative 36 over 2 1 minus I. That will be 2 plus minus root 36, 2 minus 1, which is I. The 2 I'll leave it outside. That'll be 2 plus minus 6i over 2 1 minus I. What you can do is actually just multiply by the conjugate of the complex number below. Okay, so obviously we can cancel these out also. 2 1 and 3. There you go, done. Expand everything in. There you go, expand. So that should be the answer. So that's why you can use your GC and check answer. Okay, if then also remember, you can check by just substituting this value back into the equation. Okay, so that's how we do this first part here. So let's look at part 2, B part 1. Given a W is 1 minus I, find W square. Because we can't use calculator, so we're just going to expand it slowly. So W square will just be 1 minus I square, 1 square minus 2i plus I square. That will be minus 2i. Alright, not too bad. Then W cube. Because they want us, this is W cube, we just W multiplied by W square, which we have 1 minus I minus 2i. Expand it. We get it is minus 2 minus 2i. Not an issue. Then after which W4 will just be W square multiplied by W square. I use W square because W square is quite easy to manage. So this is 4i square, which is negative 4. Okay, that's it. Then subsequently, we are asked to show, also given this one, find P and Q. I think not an issue. We just replace all the value we have. So W, well, 4. Then replace in W cube in and W square in here, and also our W. Just replace everything in. Okay, that's it. So W4 is negative 4. W cube will be minus 2 minus 2i plus 39. W square just negative 2i plus q. W is just 1 minus I plus 58. Then just expand and compare real and imaginary parts. So the next step is just group the real part here, okay, and the imaginary part to one side, so they can start comparing. Here. Oh, there's a 58. So that is always good to check. Go, this 58 over here. So by comparing the parts, we know that this is 0, 0i. So this will be 0, this will be 0 as well. Okay, comparing them. So just solve it simultaneously. 1 plus 2, because there's a q, p and q there, so I'm going to add them up. Add them up will be minus 4p. Plus 54 plus 78. In this case here, p is negative 6. Then we solve for q quite easily. Great, so we solve for p and q. So look at b part 2 using the p and q, because p and q are real. Okay, so essentially if 1 minus I is a root, then 1 plus I is also a root by conjugate roots theorem, right? Then you want to express in the product of two quadratic factors. So just basically we want to express this in terms of x w squared plus bw plus c w squared plus p dw plus e. Okay, so two quadratic factors. So we just find out one quadratic factors first, then we just do a long division. I think that will be easiest. So if this is also a root, then we know that the quadratic factor will be w minus 1 plus I, w minus 1 minus I. Okay, so we can just quickly sum them up. W, this is sum of roots, 2w plus 1 square plus 1 square, which is 2. So doing long division, we get the w square here, the w4 minus 2w cubed plus 2w square minus it out. This will be minus 4w cubed plus 37w square minus 66w. There you go. Once we do, you just make sure remainder is 0, then you can express in two quadratic factors. Okay, so that's how I do this question in a proficiently. If you have any questions at all, please do let us know and I'll see you in the next question.